Looking at this question on indices, all we need to do is to make every term in the equation to have the same base so that they will have a common base. So if you look at these ones are 2, 2, 2, we can make this 8 to be 2 as well. So we have 2 raised to the power 1 minus y times 2 raised to the power y minus 1 all over 2 raised to the power y plus 2 is equals to 8 is 2 raised to the power 3. 2 times 2 times 2 give us 8. So this 2 raised to the power 3 can replace the 8 to the power of 2 minus 3y. So this is what we have. If you put these two together, you have 2 raised to the power 1 minus y. Because of multiplication and they have a common base, the law of indices says that you add the powers. So you are going to have plus y minus 1 all over 2 raised to power y plus 2 is equal to, if you open our bracket here, you have 2 raised to power 3 times 2 give us 6, 3 times minus 3 will give us minus 9, then y. So you can decide to cross multiply or bring this one up, but let us work with cross multiplication. So that we'll have here 2 raised to power 1 minus y plus y minus y plus y is 0. 1 minus 1 is 0. So this 2 raised to power 0 is equal to, cross multiply this, you have 2 raised to power y plus 2 times 2 raised to power 6 minus 9y. Simplifying further, 2 raised to power 0 is equal to, by the law of indices, because of this multiplication and the bases are the same, you add the powers. So you have 2 raised to power y plus 2 plus 6 minus 9y, and that is 2 raised to power 0 is equal to 2 raised to power, put the like terms together, 2 plus 6 you have 8, y minus 9y you have minus 8y. So since they have the same base, you work with the powers, you cancel out the base, so 0 is equal to 8 minus 8y. Then we move the minus 8y to the left hand side. When it crosses the sign of equality, it becomes 8y is equal to 8. Then you divide both sides of the equation by the coefficient of y. 8 will cancel 8, therefore y is equal to 8 over 8 is 1. Looking at this other question, 2 raised to the power x plus y equals 16 and 4 raised to the power x minus y equals 1 over 32. Find the value of x and y. And this one is still almost the same with the one we solved previously, but this contains two equations that we are going to solve simultaneously. So the first equation is 2 raised to the power x plus y equals 16. We'll call it equation 1. The second equation is 4 raised to the power x minus y equals 1 over 32. We call it equation 2. It is good as you are solving any simultaneous equation, you carry the two equations along, even if you are not simplifying the two of them together. So if we move further, this, what we do like we did before, is to make them have a common base. From equation 1, we have 2 raised to the power x plus y is equal to 16 is a multiple of 2. That is 2 raised to the power 4 will give us 16. So this one has been achieved. Then you go to the second one, the second equation. 4 raised to the power this, the x minus y can be reduced to 2 raised to the power 2 is 4. So we have 2 raised to the power 2 into x minus y is equal to 32 raised to the power minus 1. From the law of indices, 1 over 32 can be written as 32 raised to the power minus 1, inverse, equation 2. Simplifying further, equation 1 is already done, so we can leave it that way. 2 raised to the power x plus y equals 2 raised to the power 4. But equation 2, we have 2 raised to the power. If you open this bracket, you have 2x minus 2y is equal to 32 is 2 raised to the power 5. Then multiply by minus 1. So we continue to have this time around we can now eliminate the base, because equation 1 they have a common base, so we can eliminate it to have x plus y equals 4. We call this equation 3. Then this also can happen into equation 2. The 2 will be eliminated, so that we'll have 2x minus 2y is equal to 5 multiplying minus 1, we'll have minus 5. We'll call this equation 4. So we can now solve simultaneous equation by any method of your choice, but let's use elimination. You multiply equation 3 by the coefficient of x in equation 4, that is times 2. Multiply equation 4 by the coefficient of x in equation 3, that is times 1. So when we do that, 2 times 2 you have 2x, 2 times x, you have 2x, 2 times y you have 2y, 2 times 4 you have 8. 1 multiplied every term in this second equation remains 2x minus 2y equals minus 5. So we can either eliminate x by subtraction or eliminate y by addition. But let's just use our common method of subtraction. If we subtract equation 2 from 1, 2x minus 2x will give us 0. 2y minus 2y will give you 4y. 8 minus 5 will give us 13. Therefore, y is 13 over 4. Y is 13 over 4. Then when you substitute y in any of the two equations to get x, we can substitute y in x plus y equals 4. So that we'll have x plus, instead of y, we'll write 13 over 4 equals 4. If that is the case, we say x is equal to 4 minus 13 over 4 cross the sign of equality will be negative. You have 13 over 4. So x is equal to, when you have the LCM 4 by 4 times 4, you have 16 minus 13 over 4. X therefore is equal to 16 minus 13 is 3 over 4. That implies that x is 3 over 4 and y is 13 over 4.